Here we go to C. Take a graph like showing on screen. As like previous videos, the graph will be travels from S root node to another fetched nodes. And they represents levels. From procedure graph. S to A, S to B, A to C, A to D, B to G, C to E, D to F, D to G, E to G. And G is a node. Then these uniform cost search is. These are in procedure non-sequential manner, then it's also called as from less than values in passing nodes. The process will be continued with arrows. These process it's called as uniform cost search in artificial intelligence. It's so easy solve the given graph. Uniform cost search, UCS, is a graph search algorithm used in artificial intelligence for finding the lowest cost path from a starting node to a goal node in a weighted graph. It expands nodes in order of their path cost from the start node, always choosing the node with the lowest cost so far. UCS guarantees finding the optimal solution if the cost function satisfies certain conditions, such as non-negative edge costs. Sure, here are some advantages of uniform cost search, UCS. 1. Optimality. UCS guarantees finding the optimal solution, meaning it always returns the lowest cost path from the start node to the goal node. 2. Completeness. UCS is also complete, meaning it will find a solution if one exists, provided the graph is finite. 3. Flexibility. UCS can handle graphs with different edge costs, making it suitable for a wide range of applications where the cost of traversal varies between nodes. 4. Memory efficiency. Unlike other search algorithms like A*, which use heuristics and may require storing additional information, UCS only needs to store the cost of reaching each node, making it memory efficient. 5. No overestimation. Unlike informed search algorithms like A*, UCS does not rely on heuristics that might overestimate the cost of reaching the goal, ensuring it always explores the lowest cost path. Certainly, here are some disadvantages of uniform cost search, UCS. 1. Time complexity. UCS can have high time complexity, especially in graphs with large branching factors or when the cost of edges varies significantly. This can result in longer search times compared to other algorithms, especially in scenarios where the optimal path is deeply nested. 2. Space complexity. While UCS is memory efficient in terms of storing the cost of reaching each node, it may require a large amount of memory to store all the nodes expanded during the search, particularly in graphs with many nodes. 3. No heuristic guidance. UCS does not use any heuristic information to guide its search, which means it may explore unnecessary nodes before finding the optimal solution. In some cases, informed search algorithms like A*, can be more efficient by using heuristic guidance to focus the search on the most promising paths. 4. Sensitivity to edge costs. UCS treats all edge costs equally and does not take into account the potential benefits of exploring paths with lower edge costs first. In scenarios where the edge costs vary widely, UCS may explore less promising paths before finding the optimal solution, leading to inefficiency. 5. Inability to handle negative edge costs. UCS cannot handle graphs with negative edge costs, as it assumes that all edge costs are non-negative. If negative edge costs are present, UCS may fail to find the optimal solution or may not terminate at all.